Modern frontier models process logic at speeds and depths that illuminate complex analytical pathways previously reserved for senior engineering teams. This chart of the LMSYS Chatbot Arena coding leaderboard shows Claude Opus 4.6 hitting a 1549 ELO score, far ahead of the competition. It establishes a new baseline for autonomous problem-solving. Yet, despite this raw analytical dominance, watch a developer actually use the tool in their daily work. They treat it exactly like a standard search engine. This is the chatbot fallacy. The assumption is that you type a question, wait for a text response, and close the tab. Treating a reasoning engine like a glorified FAQ bot artificially caps your return on investment and strands its actual processing potential. In a standard setup, there is no integrated system. Instead, the human acts as manual middleware between the AI and the work environment. You type a prompt, copy the generated code, paste it into your IDE, run it, hit an error, and copy-paste that error back into your browser. It is a loop of heavy friction. To utilize Claude's actual capabilities, you have to abandon this conversational loop and wire the model directly into your tech stack. Executing that shift requires understanding the cognitive architecture operating beneath the interface. We have to discard the mental model of a chat window and map how the system actually processes logic. Standard dense neural networks force every parameter to fire for every prompt, creating massive computational lag. Claude uses an optimized mixture of experts, or MOE, architecture. A central gating mechanism routes an incoming signal to specialized expert subnetworks, rather than triggering a monolithic array. By only activating necessary sectors, the model processes deep knowledge at twice the speed without the latency. This MOE routing is governed by a secondary alignment pillar, Constitutional AI. Many models are trained to be relentlessly polite, often agreeing with bad logic to satisfy the user. Constitutional AI forces Claude to prioritize strict logical verification and precision over conversational patterns. This pairing, MOE for routing efficiency and Constitutional AI for internal verification, enables the model to navigate multi-step code refactors while minimizing the hallucinated dependencies common in dense architectures. Fast, accurate processing has limited utility if the system suffers from amnesia. An isolated LLM resets every time you open a new tab. Anthropic built projects to serve as a persistent, shared working memory for an organization. Instead of writing exhausting zero-shot prompts, you ground the model by uploading up to 1 million tokens of documentation, codebases, and brand guidelines up front. Eventually, that uploaded knowledge approaches the mechanical limit of a standard context window. When met, an automated retrieval augmented generation, or RAG, pipeline activates. It seamlessly expands capacity by up to 10 times, pulling only relevant data vectors into the active context. With persistent memory and RAG scaling, the AI stops functioning as a stateless tool and operates with the long-term institutional knowledge of a senior engineer. Static, manually uploaded memory eventually goes stale. If your active database updates, the project memory does not. To break these enterprise data silos, Anthropic introduced the open-source Model Context Protocol, or MCP. It acts as a universal connector. Data packets flow autonomously, completely removing the human requirement to copy and paste data between applications. By deploying local MCP servers, you grant Claude secure, direct read access to your live enterprise environments. If a bug appears, Claude independently queries your Postgres database, pulls the active GitHub pull request, and diagnoses the root conflict. MCP transforms the model from an isolated reasoning engine into an active, integrated component of your tech stack. With the data pipelines connected, the stack requires an engine for autonomous action. For developers, Claude Code is a terminal-native agent that autonomously plans multi-file changes and runs tests. It uses context compaction, archiving bloat to survive long sessions. For non-technical users, Claude Cowork is the equivalent, operating securely within an isolated desktop virtual machine. Cowork is strictly outcome-driven. You assign a complex goal, like extracting data from 50 unstructured PDFs, and step away while the agent handles the repetitive assembly. These agentic execution environments replace the need to write sequential prompts. You no longer manage the steps, you assign the goal. When the MCP bridges, the MoE core, and the terminal agents operate in unison, you have a fully integrated architectural stack. Operating this stack requires a specific professional skill set, AI fluency. The first pillar of this fluency is describing the ultimate technical outcome, rather than micromanaging the individual steps of the process. The second pillar is delegating the execution. You grant the system the exact tools and data access it needs via the Model Context Protocol. The third pillar is discerning the results. Your time shifts from doing the manual assembly yourself to rigorously verifying the model's output. Mastering this framework upgrades your daily workflow from that of a manual laborer to an architectural orchestrator. Technical workflows now rely less on raw parameter density and more on the structural application of agentic intelligence. Remaining stuck in a restrictive conversational mindset severely limits what you can actually build as this technology evolves. Deploying Claude structurally is no longer an optional workflow optimization. It is a strict prerequisite for accessing frontier capabilities. The true value of the agentic workflow is that it clears away the repetitive assembly, freeing human talent for strategic decisions and complex problem solving. Chatbot interfaces are the start of the journey, but structural integration is where the actual work happens. Claude has transitioned from a window on a screen to a teammate operating within your codebase.